All right, folks, we're live. Here we go. We're going live, big time here. Regents Chemistry. All right, good morning. Welcome back. I hope you guys are doing well, staying safe. I hope you had a good day off yesterday from Chem Class 2. Friday.
Any student taking the AP European History exam, please report to M358. Again, any student taking the AP European History exam, please report to M358. Thank you.
All right, it's Friday. This is the last Friday for school for us. So next Friday, it's a free day. You don't have school that Friday. The next 4 Fridays either, because we didn't use the snow days. The next 4 Fridays, there's not going to be classes. I'll remind you guys as we get closer. I'm looking for a few people today. I'm looking for Alan, looking for Micaiah, looking for Joseph, and that's it. Joseph, Micaiah, Alan. If you're here, please let me know. Throw your name in the chat or on mute. Again, if you're live and in person today in class, you're more than welcome to join the Zoom. There'll be a screen in front of you. So just a little heads up, what's going on in class. I have 6 people here today. And what they're doing, they have the option, oops, lost my screen for a second. They have the option to analyze the big smart TV, or they could join the Zoom screen as well. Either way. So either they want the screen right in front of them, or they want to look up and copy your notes. Totally up to them. Just in case you want to come back too. All right, let's check out the COVID report for today. Let's see what the numbers are in the county. It's been a few days. Go through this relatively quickly. In the county, there's 320 active cases of COVID in the county. Resolved cases are 20,933. And total number of deaths in the county, total number of families that were affected by COVID complications to death are 420 people. Hospital numbers, there's 7 people in the hospital, 2 people in ICU. Those numbers have been decreasing. We're in single digits. That is an awesome sign right there. Single digits for COVID in the hospital. Vaccine numbers are slowly increasing. We're getting closer to the 70%, slowly. Once we get to that herd immunity of 60 to 70%, then things mask will start to open up more and more frequently. Let's check out the daily numbers of positive cases. Zoomed out version, checking it out. Last piece of data that we have up there, not as good as the last few days. Let's see what that numbers or those numbers are. On May 5th, there's 42 cases. The day before that, we had 23, so we almost doubled in one day. So we definitely increased quite a bit. Day before that, there was 16. Day before that, 19. Day before that, 23. Day before that, there was 41. So again, still very inconsistent with this data. We can't really predict what's going on here. There's a U-shape. What's going to happen next? Reminder, COVID's definitely in the area. Be smart, be safe, protect yourself, protect your loved ones too. If you want to get vaccinated and you're above 16 years old, you have the ability to get vaccinated. There's different pods, different locations in the county where you could do so. Check out the Oneida County website and you can figure out where to get vaccinated. They are rolling out 12, if you're 12 to 15 in the age range, or 12 and greater, they're rolling out the vaccine soon as well. That's a Pfizer vaccine. All right, let's figure out what's happened for the best class of the day. Welcome on back. Here we go. Quote of the week comes from an unknown source. Chemistry states the more energy put into a bond, the harder it is to break. Put the work in, it's going to be tough to break the bond. Today's Friday, May 7th, 2021. It's a day 4. We're going to continue on. We will finish up Unit 9, acid, bases, and salts today. We'll go through titration examples. We left off of this last time. We'll go through 2 more examples. I'll give you time in class to do the exapass. And then we'll go through the last page of the guided notes as well. That's like a quick review of the entire unit. Once we're done with that, we'll jump into unit number 10, which is organic chemistry. We'll watch a YouTube flick, we'll hammer out some notes, and then you'll be on your way. So there's only 2 more units left, organic chemistry and nuclear chemistry. We'll get through all the content, that's a guaranteed. I'm gonna make sure we get through the content. And once we're done with the content, then we'll start reviewing for the quarter 4 benchmark. We'll also start reviewing for the post test as well. No Regents. No Regents for this course. Usually is, but not this year. So that's our agenda for today. If you want to check out the flick over and over again, it's right there. There's the reference table. Just a little heads up, organic chemistry, if you take this in college, it's like a 2-semester course. A lot of you guys, if you're going to college for a science-related major, maybe engineering, maybe medicine, you might need to take organic chemistry. Maybe your older brother, older sister is taking Orgo right now, organic chemistry, and they're probably saying it's a really tough course. This level for Regents chemistry, it's relatively easy. Why? A majority of the concepts are right on the reference table. You need me for a little bit of understanding, putting it all together, and then the rest is all the reference table. Let's see. Let's get through this stuff and figure out what is organic chemistry. Micaiah, please try to get here a few minutes earlier. All right. First things first, let's open up our examples on titration. Let's figure out what that titration is again. So examples, you scroll up on your home screen, your Google Classroom page. The examples are the first thing listed. I'm going to open that up. There's 2 more questions that we have to analyze. Question number 4, question number 5 on titration. So it's been a couple days for titration. We know titration, there's a stand, there's a burette clamp, there's a burette, there's an Erlenmeyer flask there for the apparatus as well. By now, we should know what makes an acid and what makes a base a base. Acid, H+. Base, OH negative. Hydroxide, base, hydronium H+ is the acid. So you're mixing an acid and you're mixing a base. Maybe the base has a pH of 14. In this big tube here, there's going to be a pH of 14. And below, there's going to be an acid with the pH maybe of 1. So there's already a solution in there, pH of 1. You mix these 2 things together, it's going to make it a neutral solution. So you're neutralizing these 2 things. It's a really cool moment when we get to this topic because everything we talked about with acids and bases, identify what's an acid, what's a base, the pH scale, neutralization, you're putting it all together to this like climax of the unit. We're figuring out how to titrate something. You're taking all these concepts that we learned throughout the unit and putting it all together. It's easy if you understood what happened in topic 1 through 4. It's tough if you didn't pay attention. All right, question number 4, here we go. Here's a question, but before I do that, I'm gonna open up my guide notes just so we can refer to what titration is as well. Just so you guys know, this is the last day for this unit packet, the guided notes. This is due tomorrow. If you're missing something, you want to complete it today. So one last time, I'm going to go through this one packet. You may want to rewatch this video if you're missing some sections of your notes and copy out what you're missing. Copy whatever you're missing. I will add this to the stream soon after class. So here we go. I'm going to go through this one more time before I go to the examples, and then we'll hammer out the examples. So here we go. Unit 9, we talked about acid, bases, and salts. I go through this almost every class. Topic number 1, we went through acid-base properties. We also went through Arrhenius theory. Topic number 2, we talked about Bronsted-Lowry theory. Topic 3, we went through Lewis. And topic number 4, we went through the pH scale for a long time. And we also went through pH indicators. Topic 5, we went through neutralization last class, and we'll finish up with titration today. So all that stuff you should be aware of. Let's go through it. We talked about basic properties for acids. We initially said an acids are going to be tart or sour taste. They could change the color of an acid-base indicator. They could be strong or weak. Oh, acids change the color of a pH paper indicator, and they could be strong or weak. We now know more about that. Bases could be bitter, they're hazardous. Soap is a base. They feel slippery. They change the color of an acid-base indicator, and they could be strong or weak too. Not much information, but we got the ball rolling. We talked about the first theory for acid and bases, were Arrhenius theory. Arrhenius theory, we said acids are going to be H+ or H3O positive, or hydronium. We said Arrhenius bases are going to be OH negative or hydroxide. We took a look at some common acids on the reference table, and we figured out the acids, they all had an H plus, H plus, H plus, H plus. It was the first element listed. The first element is going to be a positive, and it was an H. Acids have the H plus in the compound. We talked about Arrhenius acids, meaning mono, di, and triprotic. 1, 2, and 3 different H's that can be separated. We talked about more properties with electronegativity. Didn't really care about that too much. But then we talked about Arrhenius acids with a chemical formula. Arrhenius bases, we talked about hydroxide. We analyzed an example for hydroxide formula. Sodium hydroxide yields the dissociation of Na plus OH negative. So sodium ion plus an hydroxide ion were separated. This is a decomposition reaction. We talked about common bases. Common bases, what do they have? They had the OH negative, the OH negative. They had the OH negative. Hydroxide, hydroxide, hydroxide. And we also know ammonia as a base as well. We have a basic characteristic for Arrhenius acids and Arrhenius bases. Acid, H plus, base, OH negative. We know that. That was topic 1. Topic 2, we talked about Bronsted-Lowry acid and bases. We said acids are going to be H plus donors or proton donors. The bases are H plus or proton acceptors. When we analyzed the chemical equation, we gave a chemical reaction. We highlighted one compound, and we figured out which one's most similar to that compound. We said NH3 is most similar to NH4. We put a blue box around NH3, put a blue box around NH4. They're similar. Water is most similar with OH. We colored those with the red box. We analyzed the reactant side of the equation. We figured out the water donates an H. The NH3 accepts the H. One donates, one accepts an H. We organized, figured out which one's the acid and the Bronsted-Lowry base. We went through this. We figured out conjugate acid was the same thing as a base. Conjugate base is the same thing as an acid. They're opposites. We figured out a pair. Which ones are paired up together? The 2 blue boxes are paired up together. The 2 red boxes were paired up together too. Conjugate acid base pairs. We labeled those. We looked at an example. We figured out some pairs. And then we figured out a little key for Bronsted-Lowry acid bases. We talked about Lewis briefly. We said Lewis talked about electrons. Acids accept a pair of electrons. Bases donate a pair of electrons. We went through an example. We didn't test you on the idea of Lewis, but we know it in case we take AP Chem. And then last but not least, for theories of acid bases, we put them all together just so we could have a quick reference on what is what theory, what the theories are. We talked about reactivity of metals.
Any student taking the AP European History exam, please report to M358 at this time. Again, any student taking the AP European History exam, please report to M358 at this time. Thank you.
All right, we talked about the reactivity with acids, with metals. We looked at the reactivity series. There's H2, that was our acid. We said any metal above it reacts with an acid. So if I took some hydrochloric acid and dropped it on some aluminum or tin or titanium, zinc, anything above, it's going to react with the acid. Anything below is not going to react with the acid. H2 is not going to react with copper, silver, or gold. We talked about that. Next up, we talked about indicators. I did a little demo on indicators. We looked at methyl orange. We looked at phenolphthalein. We looked at pH indicator, universal indicator. These indicators change color. We talked about that. We analyzed that. We spent a whole class talking about the pH scale. If you're missing the pH scale right from the get-go, if I see you're missing it, you didn't upload your picture, whatever it may be, you didn't complete it, you're going to start off at 80. So this is a huge part of your guided notes. Spend like 84 minutes on it. If you're missing this, you're starting off minus 20 points. The pH scale, we talked about this. We know what makes an acid an acid. We know what makes a base a base. We know about the concentration for acids. Acids have a higher concentration of H+. Bases have a higher concentration of OH negative. We know what makes a strong acid, strong base, weak acid, weak base. We know what makes something neutral. There's the pH scale. Please make sure you import your picture if you did on a separate piece of paper. We talked about neutralization. We know neutralization is going to be an acid plus a base yields salt plus water. Acid plus base yields salt plus water. We analyzed examples. And then finally, we talked about titration. There's a burette, there's an Erlenmeyer flask, stopcock, open, close, rotate at 90 degrees. We know that burette has volumes in there. It's a very accurate tool, precise and accurate tool for measuring volumes. We know there's going to be a concentration down there. We should know titration is referring to molarity and volumes of acids and bases. We went through two examples of molarity or titration. Titration formula, molarity of the acid times the volume of the acid equals the molarity of the base times the volume of the base. We saw that reference table on the calculator. We analyzed two examples in the note packet on this right here. Done. So again, if there's something you needed to put in your notes, you could have watched that portion of the video, pause it, play it, fill it in, and move on forward. Please don't slack. There's only a couple more units left, folks. Finish up the notes. You guys have been doing really well with this. A lot of you guys really filled out your notes. I appreciate it. Whatever you put into this class is what you get out of it. I told you from the beginning of the year. You copy your notes down. You understand what's going on with the note packet. You understand the examples that we do together. Then you should be able to do the exit passes. A lot of you guys, kudos to you. Did a great job with that. We're almost there, though. The last page of notes is going to be a little key, a little quick reference. We'll do it after the exit pass. So I'm going to leave this page open because we're doing titration examples. I'll do a split screen here. Hopefully you guys all know how to do a split screen. I just encountered somebody that did not know how to do a split screen. If you need help with that, I will help you. And question number 4 is the next one on titration. Here we go. Question reads, how many liters of 2.5 molarity of HCl are required to exactly neutralize 1.5 liters of 5 molarity of NaOH? Maybe you want to do this on scrap paper. I would encourage you to do it on scrap paper. Try it out. It's been a while since we've seen it, but you guys are smart. You can figure out this formula. I'm going to give you 3 minutes to try it out. And at the end of the 3 minutes, we'll go through that one as well. So 3 minutes on the clock. I'm going to sit here quietly. I'm going to highlight some key concepts to this question. I'm going to probably show you the work on how to do it, and hopefully you could solve for the answer. So here you go. Please try out question number 4, examples, right now. Please record your answer in the chat for question number 4. What's the best answer? What is the volume of the acid? Hopefully you followed along with me if you didn't know how to do this. I did highlight some components here. I figured out what the acid was. I figured out what the base was. Again, acids all unit been red. Bases all units have been blue. Please solve for that expression. I know you could do it. Solve for the expression, put it in the chat. How many liters is what we're looking for of 2.5 molarity HCl. HCl is my acid. I figured out I'm looking for a volume of the acid. I have a molarity of the acid. So VA, volume acid, MA, molarity of the acid. Those were given to you in the passage, or you're looking for. Next up, next part of the question, we have 1.5 liters volume of the base of 5 molarity NaOH. 5 molarity is the concentration, molarity of the base. How do I know NaOH is a base? OH is hydroxide, that's a base. H plus is an acid. We plugged into the formula, MaVa equals MbVb. We're solving for X. Please record your answer in the chat. I have 20 people on. 4 responses, 3 for 3, 4 for 4, 4 for 4. Solve for X. Hopefully you know how to solve for X at this point. So again, you see how I organize my data just like I did in the note packet. I have the given information to the left, I have my work to the right. Solve for X, how do we do it? We have to get X all by itself. There's X, don't touch it. You want X to be all by itself on one side of the equation. So I need to get rid of this 2.5. How do I get rid of it? It's multiplying 2.5 times X. Opposite of multiplication is dividing. So divide 2.5 to both sides. 2.5 divided by 2.5 equals 1. So that would cancel out. Cancels. And what you do to one side, you do it to the other side. I know you heard that 100 times in math class. What you do to one side, you do to the other. There you go. Let's see if we get the right answer. Throw in the calculator. Here we go. We have 5.0 times 1.5 equals 7.5. You can see that. Equals. Take that number and divide it by 2.5. I got an answer of 3. 3 what? 3 liters. Let's see if that's a choice. 3 liters. Yeah, choice C. If you responded, you put choice C as the best answer as well. Number 4, the best answer is going to be choice C. Again, there's a work for that. Anybody have any questions on question number 4? All right, last question on the examples for us to really understand together. Then I'm going to let you do the rest on your own for Exapass. Number 5, here we go. A student neutralized 16.4 milliliters of HCl by adding 12.7 milliliters of 0.620 molarity of KOH. What is the molarity of HCl? Again, I'm giving you 3 minutes again. Take the same exact approach that we did the last probably 7 or 8 questions. Figure out what's given to you, figure out what they're asking to solve for, and then figure out the answer. 3 minutes on the clock. I will sit here quietly and, I'll sit here quietly and try to attempt it myself and color code it. Please try it out. 3 minutes on the clock starting now. Okay, please post your answer in the chat once you get an answer for question number 5. Please record your answer in the chat for number 5. Thank you, thank you, thank you. Thank you. 4 for 4. Thank you, Michael. Thank you, Jordan. Thank you, Tintin. Thanks, Joey. Nadina, thank you. Thanks, Zen. All right, thanks for the responses. Hopefully you guys remember how to do titration. I highlighted my acids in the text. I highlighted my bases in the text. I organized my known values, and then I plugged it in. Hopefully you can do that. All right, solving for x. Let's see what we get when we solve for x. Get x all by itself. You want x all by itself on one side of the equation. It's upstairs, so I'm not touching the x. Let's get rid of 16.4. How do we get rid of it? You divide 16.4 to both sides. What you do to one side, you do to the other side. So dividing 16.4 to both sides, it cancels over here. And then we have to just calculate this equation right there. Let's do it. Let's do this. 0.620 multiplied by 12.7 times 12.7 equals 7.874. Take that number and divide it by 16.4. So divide that by 16.4. I got an answer of 0.4801219. Let's see if that's a choice. 0.480. Good. A lot of you guys picked choice B. B is the best answer. B is the best choice for question number 5. There's a work for it. The work, the answer on the calculator. There you go. 0.480. One last thing to note really quick. You could check out sig figs. Where to end the molarity. Where do you put the answer to? This is a molarity. The molarity is represented to the thousandths place. Your answer should be represented to the thousandths place too for the other molarity. There's a molarity, thousandths place. 5, the best answer is going to be choice B. All right, there's the examples on titrations. Does anybody have any questions on how we did number 5? Any questions? Number 5. All right, guys, I'm going to give you some time to work on the exit pass. So again, the examples you do not have to submit. I'm not grading them. Those are for you to learn from. Please open up the exit pass on this topic. Exit pass, Unit 9, Topic 5, titration. I think there's like 5 questions or so. Some of you guys already did it. Cool. You guys moved on. You knew how to do this one. There are 6 questions. There's 6 questions, and I want to make sure you guys have enough time to complete it. So I'm giving you 15 minutes to work on this right now. So if you already complete it, you have 15 minutes free. At 12:30, we'll come back together. We'll move on forward from this topic. I'm going to put you in breakout rooms. If anybody has any questions, feel free to ask for help on the questions. At 12:30, though, we're going to move on forward. This assignment is due tomorrow, though. So please work on it. Please complete it right now. It's due tomorrow. Please join the breakout room. Please complete exit pass. Unit 9, Topic 5, titration. Exit pass. This is graded. Show me what you know from the example. Show me what you know from the notes. Do you know how to do titration? Again, please join the breakout room. Please complete exit pass, Unit 9, Topic 5, 5B, titration. You have now till 12:30 to work on it. If you need help, ask for help. Join the breakout room. Please join the breakout room. Regardless if you already did it, please join the breakout room. John, Kim, Micaiah, Nidal, please join the breakout room regardless. Thank you. Please join the breakout room. Good job, Jeffrey. Pick up your bat, buddy. Good. Run, Jeff, run! Run, Jeff, run! All right, guys, 30 seconds left, and then we'll switch gears. Hopefully you finished up the assessment. A lot of people in person finished up quickly. Hopefully you did too. All right, welcome back. Hopefully you finish up the exit pass. If you did not complete it, it is going to be due tomorrow. So please, please, please get that done by tomorrow. Submit your work, all set. If you guys didn't do it yet. All right, back to the homepage. Where are we? We have to finish up our guided notes for the unit. That will be due tomorrow too. So let's open that up. Let's figure out what we have left for unit number 9, acid, bases, and salts. All right, unit 9, what's left for the unit? We have this last page, which is going to fly by. It's super simple. It's a quick little cheat sheet, quick little reference guide for determining acid, bases, salts. Basically, it's a quick reference for each of the topics that we have here. So it's honestly going to take like 5 minutes to do this. Last page of notes, 5 minutes. Here we go. Acid and base theories. We should know what makes an acid an acid. You should be aware what makes an acid, and a base, and a base. You should know the 3 theories too. So what I'm going to do here, this text box, this little chart is the exact same thing we did at the end of topic number 3. We organized the 3 theories together right there. Mine's on page 6. What I'm going to do, I'm going to highlight this whole text box. I'm going to copy it. Copy by hitting Control-C. I'm copying that text box. I'm going to paste it there instead. I'm going to highlight these. I'm going to paste it top left corner, paste it right there. We should know the 3 theories for acids and bases. You should be aware of them at least. At least the first 2 you should definitely know. Arrhenius theory, Bronsted-Lowry, Lewis theory. Arrhenius acid is H+ or hydronium. Arrhenius base is OH- or hydroxide. Bronsted-Lowry acid, H+ or proton donor. Base, H+ or proton acceptor. Again, I just copied and pasted that from the notes, page 6, 5. This one, a little bit different. Acids typically have what in their compound? What do acids typically have? Anybody throw it in the chat? Unmute. What elements do acids typically have? Throw in the chat. Unmute. Use the reference table if you need to. Please put in the chat, unmute. What do acids typically have in the compound? It's a good question. Anybody in here know? Acids typically have what? Huh? Hydrogen, H+. Good, thanks, Alex. Yeah, someone in class told me that as well. They typically have the H+, H, control period, plus, or the H3O+, either one of those. They have the H+. You can look at the common acids and you notice that they all have H+, 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 or hydronium, H3O. Whoops, not M, H3O+. The name of that is going to be hydronium. Definitely hydronium. Hydronium. Sounds like a flower. Bases typically have what in their compound? Anybody? OH negative. Hydroxide. Good. There you go. Basically taking what has Arrhenius's concept and putting it in. Bases typically have OH negative. And that is called hydroxide. Definitely be aware of that. Hydroxide. acid, bases. Last page of the reference table, you can find those answers too. Titration says acid's going to be H plus, base is going to be OH negative. Really quick, let me check that out quick. Titration formula, there it is. Oh, acid, H plus, base, OH minus. Yeah, so was there too. The pH scale, you can copy and paste the pH scale that you did before, or you can pull up a new text box or a new file and find another pH scale. I'm going to do that. I'll find a new image for this one. I'm going to type in pH scale with H plus and OH negative. I want a little bit more in-depth example. I'm going to use pH scale with H plus and OH negative. I'm going to images and find a nice image that you could relate to for pH scale, or one that might look similar to what we did in class. I don't care which one you pick. Throw a pH scale in there. I'm going to use this one this time. That's pretty cool. I'll take this pH scale, use any one you like. Pop this right into our notes right there. pH scale. Good. It gives us a couple more examples of like things you could think of. Does not have to be this image. Could be something else. There's a pH scale. You could take the one we created in class. I don't care. All right, pH scale done. Yes. Want to. All right, so there's a pH scale. Good. Then the neutralization reaction. Neutralization reaction, what is that? We should know what neutralization is. Scroll back on up. Let's find neutralization. Neutralization. Oh, there it is. Acid plus base yields water plus salt. I'm going to copy that right there. I'm going to copy that. Same color. I like the color coding. I paste it in with neutralization. Neutralization. Acid plus base yields salt plus water. Water plus salt. We know about that. And last but not least, the titration formula we just analyzed in class. I copy and paste the molarity of the acid times volume acid equals the molarity of the base times the volume of the base. Told you it wouldn't take very long to do this if you did the work. There's the formula. Molarity of the acid times volume of acid equals molarity of the base times the volume of the base. That is the last thing for the notes. So again, this should be like a quick little reference guide for everything, for acids, bases, salts, formulas, anything you need for the unit. Hopefully you can look at this last page and hopefully you can remember different or more in-depth ideas of each topic. I'm gonna try it, I'll squeeze it all on one page. You don't have to, but I'm gonna make it fit on one page. Then if you need a reference guide for the unit, there you go. All right, guys, once you're all set with this last page of notes, you could submit this to myself. You could share it with me if you're ready. You still do have some time to complete it. You know what? If you do not finish it by tomorrow, I'll make it due by next Saturday. So next Saturday, I'm gonna give you another week to complete it if you need to. You have to complete this packet of notes by next Saturday. So I will not grade acid bases until next Saturday. You need more time, you got more time. By next Saturday. So again, share it with myself. It's 100 points. Hopefully you have it completed. Hopefully you're still taking pride in your notes. By the end of the year, you can print out all your notes, your notebook, and you'll have a pretty cool note packet for the year of Regents chemistry. I'm doing it. I'm doing it for each one of my classes and printing it out. I'm like, wow, this is pretty impressive. It's your textbook of Regents chemistry, really. Again, share it with myself if you didn't do it. If you're not ready, it has to be done by next Saturday. All right, guys, that is acid, bases, and salts done. What's up, Tristan? Yeah, I'll get you past in a second. All right, so what I'm going to do next, after doing that, I'm going to switch gears. We're all done acid, bases, and salts. One moment, please. Your guided notes for the hard copy, and then you have a hard digital copy online. You have to submit both of them too, okay? Thank you. So again, so if you only start halfway in between, I need the digital copy too. Don't forget that. All right, one moment, folks. Someone needs to go to the bathroom. It's not that easy as it being home. Next up on plate, organic chemistry. You're welcome. So what is organic chemistry? Sounds crazy. Organic chemistry is dealing with carbon atoms and the interaction of carbon atoms. This unit, I told you before, it could be really complicated if you don't understand the basic ideas of organic chemistry. It's an easy unit for Regents chemistry because a lot of the stuff is given to us in the reference table. If you pay attention, you understand the basics idea of organic chemistry, what I teach, the notes, it will be easy. If you don't go through your notes, you don't go through examples, this unit will be hard for us. This unit will definitely take some time. If you look at the guided notes above, there's a PowerPoint for those of you who like to copy and paste your notes into the guided notes. There's a PowerPoint for that. There's your guided notes, which will open up in a few minutes. And then you also have the textbook for the chapter. There's a online version of the textbook. There's two different portions to the online version. And then we'll go to the examples next time. But anyways, the guided notes, it's a thick packet. There's 30 pages of notes. But with that, the examples are like half the page. There's one example that's half a page. Another example, another half the page. But we'll get through this. It's going to go really quick, this unit. Here we go. Organic chemistry. What is it? Try to get a couple things out of this video. She does a good job.
Welcome to part 1 of the Organic Chemistry Introduction. I'm Melissa Maribel, your personal tutor, and the most important element for organic chemistry is carbon. Remember, carbon has 4 valence electrons. It means it could have 4 bonds. Knowing this, let's go over the 4 different ways a molecule can be represented. The first way is the typical molecular formula. The second way is the structural formula, which looks like a typical Lewis structure. The third way is called a condensed structural formula. To write this formula, we looked at the structural formula where on the first carbon to the left, there are 3 hydrogens attached. This is why we have CH3. Next, the middle carbon only has 2 hydrogens, so CH2. And the last carbon to the right has 3 hydrogens, so CH3. The fourth way is what you will most commonly see throughout the entire semester. It is the skeletal formula, also referred to as a line diagram, where each point represents a carbon and the hydrogens are not shown. This is where knowing that carbon wants 4 bonds is going to be very important. This is what the structure would look like if we drew in the hydrogens. At this carbon, we already have 1 bond, so we are missing 3 more bonds, which must be 3 hydrogens. Next, the middle carbon already has 2 bonds, so we need 2 more, so we have 2 hydrogens. And this last carbon already has 1 bond, so we need 3 more bonds, so 3 more hydrogens. To make sure you get this down and don't miss anything on your exam, make sure to pause the video and try this question out, and we'll go over the answers together. Okay, here are the answers. The structural formula consists of 4 carbons and 10 hydrogens. So this first carbon needs 3 hydrogens. Next carbon has 2 bonds, so it needs 2 hydrogens. Same goes for this carbon. And this last carbon has 1 bond, so it needs 3 hydrogens. So this is our structural formula. Using the structural formula, we'll write the condensed structural formula, where this first carbon has 3 hydrogens, so CH3. The next carbon has 2 hydrogens, so CH2. Same for the next carbon, so CH2. And the last carbon has 3 hydrogens, so CH3. This is our condensed structural formula. Now for the skeletal formula. Since there are 4 carbons, we need 4 points. There is a trick to drawing this right each time. If you were to count 1, 2, 3, 4, we actually drew too many carbons. We drew 1, 2, 3, 4, 5, but we just wanted 4. So if you count to 1 less carbon than what you're originally looking for, then you will draw the correct amount of carbons each time. So in our case, we will count to 3 when drawing the lines. So 1, 2, 3, and we really have 1, 2, 3, 4 carbons. This is the correct skeletal formula. These molecules that we are working with are called hydrocarbons. A hydrocarbon consists of only hydrogens and carbons. There are different types of hydrocarbons. This is based on the type of bonds that are between the carbon atoms. Alkanes have single bonds. Alkenes have at least 1 double bond, and alkynes have at least 1 triple bond. You will later get into naming different types of structures, so know that the ending is very important. If something ends in -ane, it's an alkane, meaning it only has single bonds. The ending -ene means it's an alkene, which has a double bond, and the ending of -ine makes it an alkyne, which means it's a triple bond. This all is talking about the major carbon chain or longest carbon chain. But we can also have something known as a substituent, which is an atom or groups of atoms that replaces a hydrogen and gets attached to the carbon in the longest carbon chain. Think of it this way. The longest carbon chain is like the body of a person, and the substituents are the arms or legs, because that's what's sticking out of the body. Here's a list of the most common substituents you will first see. These specific substituents are also referred to as alkyl groups. An alkyl group is made up of only carbons and hydrogens. It is also defined as an alkane that is missing 1 hydrogen. The first alkyl group is methyl. This has only 1 carbon. Next is ethyl. This has 2 carbons. Then propyl has 3 carbons, and butyl has 4 carbons. You will definitely be tested on functional groups, which is what I'll be covering in part 2. You can find that right over here. And remember, stay determined. You can do this.
All right, you definitely could do this. This unit is going to take some time to get through, but if you understand the basics, you can do it. You can do anything, just like this class. All right, let's focus on this unit. Next unit, organic chemistry. Hopefully we got a couple things out of that video. Hopefully you know organic chemistry is going to be focusing on one specific element. What element? Is going to be the carbon. So let's look at carbon for 1 second. Let's check it out. Why is our whole unit devoted just for carbon? Or why is organic chemistry relating to carbons? So carbon atoms, the one in the center, it's a key for us. If we check out carbon, that key, there it is. We notice that carbon has 4 valence electrons. Total electrons 2-4. Total electrons would be 6. But the valence electrons, there's 4. What does that mean? That means there's 4 valence electrons. There's 4 dots around the carbon. 1 to the north, 1 to the east, south, and west. That also means that carbon can bond with a bond right there, another bond there, another bond there, and another bond there. It could potentially have 4 bonds attaching to it. What could attach? Maybe a hydrogen, or it could even attach to a carbon too. So this would be something called a methane, CH4. But carbon could attach to another carbon, to another carbon, to another carbon to make a long chain ring or network. When I think of organic chemistry, I think of particles like plastics, I think of oils, I think of gases. And in that, they're all containing carbons. Let's figure out what organic chemistry is. So again, please open up their guided notes on organic chemistry. We're not gonna be able to get too much done today, but we'll start it. Guided notes, please open it up. This is your own copy. It's 100 points. Hopefully you get done with it by May 29th. Please put your name on top of your copy. If you're at home, I'm going to make a copy. You saw my routine just so I don't mess up my initial copy. This is period 6-7. The best class of the day, or the second best class of the day. It's got to be up there. As long as it's top 5, I don't care. So period 6-7, throw your name on there. And we'll label this. All right, so again, you know my routine. I'm gonna highlight, I'm gonna cap lock, I'm gonna bold. Let's go red for this unit. All right, so period 6-7. And I'm gonna put the date of when we started this unit. May 7th. Can't believe there's no more Fridays. Last Friday today. I don't believe so, unless you have a test. I'll have to check that, make sure though. May 7th, 2021. And there's gonna be 6 different topics that we're gonna analyze within this unit. 6 topics. Unit number 10, organic chemistry. The first topic is gonna be about organic basics. We'll talk about hydrocarbons as well. Next class, more likely. We'll talk about homologous series for topic 2. We'll figure out what that is behind me. We'll talk about topic 3, which is isomers. Topic 4 is going to be naming these organic compounds. Topic 5 is functional groups. Topic number 6 is going to be organic reactions. Let's get going. Topic number 1, hydrocarbons. Let's figure out what the heck it is. Organic basics and hydrocarbons. Organic chemistry is the study of carbon and most carbon-containing compounds. So it's going to have carbon in it. Organic chemistry is dealing with the study of carbon atoms. So carbon, and most carbon-containing compounds where carbon is bonded covalently. Covalent bonds, there it is again, covalent bonds. When we talked about chemical bonding, I told you ionic bonding took a long time, and then covalent bond, we'll talk about it later in the year. This is the time. Covalent bonds, carbon atoms. Covalent bonds, 2 nonmetals bonding together. They share electrons. They could be polar or they could be nonpolar. We talked about 2 twins playing tug of war. Nonpolar, they're sharing electrons evenly. They're pulling them evenly. Maybe you playing tug of war with your younger brother. That's going to be a polar bond. One's going to be a hawk. The number of carbon or organic compounds, carbon, or organic compounds far exceeds the number of inorganic compounds. There's more organic compounds than inorganic compounds. So there's more bonds with carbons than inorganic. What's inorganic referring to? Inorganic is going to be like a covalent bond, a metal and a nonmetal. Organic is going to be 2 nonmetals bonding together. Why is this? Because carbon has the ability to bond with other carbon atoms to form chains, rings, and networks. We'll figure all that stuff out within the unit. A chain of carbons, a ring of carbon, or network of carbon. So that video that we just watched analyzed some chains of carbons. A ring of carbon, we'll analyze butane, butene. And networks are going to be groups that branch off of that. Carbons can form a bond with 4 other atoms. I'm going to put carbon up there as well. Carbon, just so we know, can form a bond. Can form a bond with 4 other atoms. 4 other atoms. Put the guide notes on your desk, and it's a new unit, no problem. Carbon can bond with 4 other atoms. I just highlighted that before. I looked at the reference table. We looked at the valence electrons for carbon too. So, yeah. Yep. Let's draw a Lewis dot diagram for carbon in that box. So you should be able to do the Lewis dot diagram of carbon there. I'll draw it with you in a second. Hope your headache clears and have fun tonight. We'll see you. All right, take care. All right. So anyways, carbon Lewis dot diagram, please double click on the image. Let's make a Lewis dot diagram for carbon. We know carbon's going to have a symbol of C. So click on that text box, put a C in there. I'm going to blow the C up, make it a lot larger. Let's make it 60. Go bigger, go home. 60. Let's center it up. That's the kernel. That's the symbol. The symbol for carbon is C. We know carbon, the kernel, represents protons, neutrons, and non-valence electrons. Around that are going to be the valence electrons. I'm going to go to shape, shapes. I'm going to take the oval, or you can make the smiley face. Some of you guys still pick the smiley face and made me smile when I graded your notes. I filled it in black. I'm going to copy it by hitting Control C. I'm going to paste it 3 more times. Control V, Control V, Control V. I'm going to take those valence electrons and I'm going to place them around carbon. The first valence electron goes to the north side. It's going to Charlie's for a piece of pizza. The second one goes to the east side. It's going to hit up either Pizza Box, Slice, Oskin Eats, Parkway Pizza for a slice. South side is going to get a slice of pizza from Slice. I don't know of any other pizzerias in South Utica. In West Utica, I don't know where there's a good slice of pizza. I don't know any good pizza joints in West Utica. If you do, let me know. I'm always looking for a good pizzeria. But anyways, the Lewis dot diagram for carbon, there's 4 valence electrons. We know there's room for 4 more electrons. Don't put this red dot in there. But 4 more bonds could definitely bond within that. That's a Lewis dot diagram for carbon. Let's save that image and close it. Save that image and close. I'm going to refresh my screen. Hopefully it saves. Hopefully you don't have the same problems that I have here. And actually, once we get that last image in there, I'm going to call it quits for today. There's only a few more minutes of class. Again, please do not forget to do the exit pass on titration. Please do not forget to submit your notes for acid, bases, and salts as well. Did to me again. So again, organic chemistry, dealing with carbon atoms. We'll pick up on this topic next time. short week next week. Only 4 days of school. 4 days of school here on forward. So that is it for today, guys. Have a great day. Have a good weekend. We'll make a decision. Stay safe. Hopefully from now at the end of the class, I can get this image to really save in here. Have a good day, guys. We'll see you later. I'll go back to notes in a second. Third time the charm. Third time the charm. Save's good to go. All right, guys. We'll see you later. Have a great day. Make good decisions. Stay safe. Thank you so much. Appreciate it. Does this work? Is this?
Have a good day, Mr. Brown.
You as well. Take care. Bye, guys. Have a good one. See you later. If you're fortunate enough to have mom in your life, don't forget Mom's Day's Monday or Sunday, not Monday, Sunday. Mom's Day. Don't forget about that person or whoever's helping you out in life, whoever that may be. Give them a little love. Bye, guys. Have a good day. Say Nadina. Goodbye.